Hello friends, this video on relations and functions part 9 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 8. For example, we have to show that relation in the set 1, 2, 3 is given by 1, 1, 2, 1, 2, 2, 3, 3, 1, 2, and 2, 3. It's reflexive but not symmetric or transitive. So if there is a set A which has value 1, 2, 3, we generally get A cross A, and that will have value 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. Correct? These values will get as part of A cross A. Now, you will get a subset of this as part of relation. So, relation will have some values 1, 1, 2, 2, 3, 3, 1, 2, and 2, 3. So these values are nothing but a relation. So I got this relation as this. Now I have to prove that it is reflexive but not symmetric or transitive. I told reflection means reflection of a guy, a reflection of yourself. That means if A1 exists, A1, A1 should exist. Correct? So if you see, if 1 exists, all the number 1, 1 exists, 2, 2, 2 exists, 3, 3, 3 exists. So all the elements in this set are, for those elements, AI, AI exist. Correct? 1, 1, 2, 2, 3, 1. So it is reflexive. Done. Now, whether it is symmetric or not. For symmetric, I told, if A1, A2 exists, then A2, A1 should also exist. Now if you see, 1, 2 exists, but 2, 1 is not there. Correct? 1, 2 is there, but 2, 1 is not there. So if you see, this is not symmetric. You have to just find one instance where 1, 2 is there, 2, 1 is not there. Or if you could have taken this also, 2, 3 is there, 3, 2 is not there. This is not symmetric. Similarly, for transitive, I told you if A1, A2 exists, A2, A3 exists, then we have to confirm that A1, A3 should also exist for all items. So if you see here, 1, 1 exists, number starting with 1 is 1, 2 exists, that will not fail. We can take this one, 3, we'll take 1, 2 and 2, 3 actually. So 1, 2 exists, number starting with 2, this will take 2, 3, 2, 3 exists. So we merge this, you get 1, 3, 1, 3 doesn't exist. So if you see, this statement is falsified here. A1, A2 exists, A2, A3 exists, but A1, A3 is not there. So this is not symmetric. Please note here, don't say that 1, 1 exists, I'll take this value and I'll take 1, 2 exists, let's suppose. And if you merge this, you get 1, 2, all exist. You can't say that it is transitive. Because even if one pair is there for which this statement is false, that means this is not transitive. For example, there are 10 scenarios, out of 10, 9 are true, that means all are existing, but only one scenario where it doesn't exist, that means the whole relation is not transitive. For a relation to be transitive, this has to be true for any 3 elements in the set. Similarly for reflexive and symmetric. Correct? Let's take one more example. We have to show that relation in the set Z of integers given by R, AB, where 2 divides A minus B is an equivalence relation. Now, for a relation to be equivalence, it has to be reflexive, symmetric, and transitive. First, we'll prove that it is reflexive. For reflexive, I told it's a mirror reflection. That means we'll take A, A. That is A, A should exist for all A, for all A, where A is nothing but any integer. Because we are talking about set of integers and we are taking any element A comma A to exist. Now the question says 2 divides A comma A. 2 divides A comma A minus A comma A, that is A minus A. Now we say A comma A, this is A minus A. That is 2 divides 0. Yes, 2 divides 0. For any A that is integer, 2 divides 0. A minus A is 0. So that means we can say that this is reflexive. One part of that. Second is symmetric. Symmetric says that if A1, A2 exists, then A2, A1 should also exist. That means if I say that if 2 divides, there is element A1, A2, A1 minus A2, because if there is element A1, A2, that means 2 divides A1 minus A2. That implies that 2 also divides A2 minus A1. Correct. See, if A1 minus A2 is 4, A2 minus A1 will be minus 4. Correct. So if this divides 2, this will also divides 2. If A1 minus A2 is 5, and then A2 minus A1 will be minus 5. If it doesn't divide, this also doesn't divide. So if this is true for 4, this will also be true for minus 4. Because if you see A2 minus A1 or A1 minus A2 is just a sign difference, minus or plus, but the number is same. So if a number is divided by A1 minus A2, it will be divided by A2 minus A1 also. So this is symmetric. This part is also short. Now the third is transit. For a number to be transitive, I told that if A1, A2 exists and A2, A3 exists, that implies if A1, A2 exists and A2, A3 that implies A1, A3 should also exist. For example, if you see now, if I say 2 divides A1 minus A2 and I say 2 divides A2 minus A3, because this 2 exists, this by default it implies 2 divides A1 minus A3. Why? I can take some example. Let's suppose A1, A2 and A3. A1 is 1, this is 5, and this is, let's suppose, 9. 5 minus 1, 4. 4 by 2 possible. 9 minus 5, 4 possible. 4 by 2 possible. Similarly, if you take 9 minus 1, this will be possible. If you take the even sets, if you take this is 2, this is, let's suppose, 4 and this is 6. 4 minus 2, 2, 2 divides 2 possible. 6 minus 4, 2, 2 divides 2 possible. 6 minus 2 divides 2 possible. Because, see, if you take either all odd or all even, in any of this case, odd minus odd is even, even minus even is equal. So, even number will be divided by 2. So, with this we come to conclusion that this is a transitive, because if you take any number A1, A2, A3, any real results, if A1 minus A2 divides 2 and A2 minus A3 divides 2, A1 minus A3 will also divide. Now, thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.